Hello, community. Large language models for code. What are the best solutions? And can we learn those models new code? Well, at first we start with a GPT-4 comparison to StarChat, and here we go. Let's explore GPT-4. We have a very simple message. Write a Python code sequence to calculate the surface of a sphere. So, starts, yes. So our formula is 4πr squared. Beautiful. Math, calculate surface, return, yes. Enter the radius, surface calculated. Script will prompt the user to enter the radius of the sphere. So this looks nice, and you see we do not have even here code interpreter here in the model GPT-4, but this is just the normal conversational AI. Now we use here the same message, and I adjusted just some of the parameters. So we can get out of the way. So we say send. Let's see what the chat is. And now with StarChat, we get this sequence. As you can see, this is interesting. A lot of text, a lot of enter choice. Please enter max radius. Okay, so first attempt, I would say this is calculate circumference. You see, the definition, the name of the function is so important. And then any comments or anything in the print command is, of course, red. So yeah, there is a lot of things going on, but I think we are quite sure that this is not exactly what I'm looking for. So let's do it again. Clear chat. And send this. And as you can see, it is not able to do that. So let's make another complete clear. StarChat playground. Enter your message here. I'm sure there will come a time where we find it. Here we go. You see, it happened. You just have to be a little bit more patient. So there is now, okay. It's not so nice like here in GPT-4, but here import math, yeah, define radius, sets already in radius for us. So at least here 4πr squared, this is the right formula, calculates the volume, okay, and print surface area, okay, use system, user defined. So you see, you do not always get immediately the right result with StarChat here, because as I showed you, this is here an alpha version. It's a variant of the StarCoderBase variant, and it was fine-tuned on the Dolly and the Open Assistant dataset to be a coding assistant, and it only has 16 billion parameter. And on the left side, we have something that goes minimum 10 or 20 or 30 times more. So you see, this is our first test. In my second example, I say write a Python code sequence for a sentence transformer in SBIRD. See? A sentence transformer library specifically designed to produce sentence embedding. Yes, sentence transformer. Hey, did just a nice model. Yes, this is a sample sentence. Encode the sentences, model encode. Yes. So what it does, it says, okay, this is our sentence. And here I show you the vector embeddings. Yes, smaller but similar performance. Install the sentence transformer. You can install this with pip install sentence transformers. Substantial computational resources. Yeah, okay. So it gives us the pip install command from sentence transformer, import sentence transformer, load the model. Beautiful. This, I would say, is a 100% answer that I can use here later on. So let's do here the same now again. Let's clear the chat. Okay. Now it goes on another level, but interesting. So here we go. First, you need to install Hugging Face Transformer Library by pip install transformers. Okay. Next, you import the modules, auto tokenizer, a BERT model, import torch, okay. Then we have the tokenizer from pre-trained, yes, sentence. The same model, old mini language model L6 version 2, this is identical. This is interesting, okay, so there is one dominant example from the training dataset, both models incorporated from GitHub. And then you have your sentence A, B, C, and then you have also the encodings. So you say for the sentence in the set of sentences, I have a tokenizer, return a PyTorch tensor, the padding is true, yeah, truncation is true, these are the model outputs, yes. And append the embeddings, the resulting embeddings now contain the sentence representation encoded as number arrays, as vectors. You can then transform any downstream task, clustering classification with this representation. So this is nice. Yes, absolutely. Since I have not specified examples, both did. So, but now comes an interesting part. I have the bakers at the Beverly Hills Bakery bake 200 loaves of bread. They sold 93 in the morning, 8 breads at noon, and donated 39 loaves in the afternoon. A grocery store returned 10 unsold loaves. How many loaves of bread did they have left in the bakery? So, let's see, you have done the calculation. Yes, you know what should be the outcome. $70. Yeah, beautiful. You can even say, here, write a Python code for this example. Yes, yes, yes. We define here our variables. Sold in the morning, sold at noon, and donated. Beautiful. So he gets right how many left the bakery. And then we have the number of the baked loaves minus total sold and donated plus the return loaves. Beautiful. What you can do, what they like, and this is a tip for you, tell them to write a Python function. Because as you see now, we have defined a function that goes with any values of those parameters. So let's do now the same here. Okay, this sounds interesting, yeah. We can deduce that there were a total of 500 loaves produced over their lifetime. Okay, this is because, oh wow. Okay, 500 is, okay. Okay, this is interesting. Now, if you want to know why this happens, so we say, write a Python function of this and check step by step. So let's see. Here we go. There we have now a copy function. Hey, this is nice. Now we have a copy function. Remaining bakery, calculate, yes. Sales quarter. Oh, wow. Look what happened now. Calculate the number of breads made each day during a shift. So suddenly somewhere in his training example, it was exactly this example, the number of breads made each day during shifts. Interesting. Sales quarter, sales, okay. So you see, it really depends here if we use here the chat functionality. For the chat playground, you see here a smaller version that has in addition just been trained on the Dolly and the Open Assistant dataset, which is maybe not enough for the quality of GPT-4, you see, but it's a nice start. It is starting and it is open source, and this is the most important, but they have quite some way to go from the open source side. On the other side here, if you look here at GPT-4, and please note that I have not the code interpreter activated, this is the normal GPT-4. So this was it for the live comparison, and now we go here to our content. So the first time, for the first point, it was text to code. This was the most difficult task. You give it a human language expression, and you want to have, for example, the Python code. Now, second is code implementation. Code implementation is much easier because you give it a piece of code and you just want to complete here the code sequence. And code summarization now is the opposite. You have a lot of code, a code sequence, and you want to have a human language explanation. What the hell is this code doing? So let's have a look in detail. And as you can see here, I had a short poll, and you said, hey, we want to see here with close to 60% Hugging Face StarCoder. This is what we're interested in. So this is insight number 1. We're looking at StarCoder today. And the second is, and you noticed this in the live demo, that now suddenly in our program sequence, we have now all the comments are now really important because they tell the system, hey, what is happening? And they like here also to look here at the name of the functions. Because whenever you define a function, here exactly this one, with here encode sentences, parenthesis sentences, this now tells exactly what is the following function. So whenever you code now, please be aware the machines are looking here for all the comments, for all the explanation in the header. And if you define function or if you define classes or whatever you define, choose here, please, your name of the function wisely. Okay, and on we go. StarCoder. StarCoder is amazing because look at here the community. You have Hugging Face, ServiceNow. You have Carnegie Mellon, Johns Hopkins University, Leipzig, Queen Mary University of London, whatever, IBM Research, Notre Dame, Alan Turing Institute, Forschungszentrum Jülich. So you see, May 9th, 2023, we had here the publication of StarCoder in the archive preprint. Now, what is StarCoder? StarCoder is a variety of LLMs. So let me show you. At first, we have a kind of an open source. We have an open rail license agreement, which is great because it is open for research. And we have the StarCoder base. This StarCoder base was trained on 80 plus framework languages, programming languages from the stack. And then we have, on top of the base, we have now StarCoder itself. And this is StarCoder base plus here a dataset, a training dataset with 35 billion Python tokens in addition. So if you want to go with general languages, it's the base version. If you look here for the Python powerhouse, you go with StarCoder. Now, I will show you that there's also an encoder model here, StarEncoder, and there's something about the personal information. So beautiful. What is the stack? This is a source code library, 6.4 terabyte of information, and it includes 358 programming languages from permissive licenses. And StarCoder itself now is a 15.5 billion parameter model with some unique features, and we have an 8K context token length, and this results in a lot of architectural choices. First of all, the infilling capabilities and multi-query attention. Let me show you what I mean. The StarCoder itself, now the model, is a GPT-2 model. Yes, I know, you see here are now the license agreements. They had to go with GPT-2, multi-query attention, fill in the middle objective. And as I just showed you, the StarCoder and the StarCoder base version were trained on the GitHub code, and as such is not an instruction model. So anything like write the function and computes the square root do not work well. This is why the StarChat that I showed you at the very beginning was a demonstration project that was additionally trained on more code to have this chat version available. But what we are looking now is StarCoder and StarCoderBase, so no chatty version, but really a Python focused version. Yeah, if you want to know a little bit more, the pre-training tokens exceeded 1 trillion. The training happened on a cluster of GPUs, 512 Tesla A100 data center GPUs, and the training time was about 24 days, and I suppose nights. Yeah, StarChat is important because it is an open source demonstration, and it is so important to have for the community open source things that we can look at, we can experiment, we can open up, we can check, we can modify, we can optimize. So although it might not have yet the power of a GPT-4 system, it is important, and I want to show you it is there and we can optimize it. And the second half of the video will show you how we can further fine-tune here the StarCoder and the StarCoderBase model. If you are working on a specific project, you can fine-tune it. You can optimize the performance of the system. Just to be complete, the StarChat is, as I told you, only on the base code, StarCoderBase variant, and it was fine-tuned here with the chatting ability of the Dolly and the Open Assistant dataset. So, although it has also 16 billion parameters, yes, but this is just a demonstration, but we are focused now on the real StarCoder and StarCoderBase, and here we look at our data. So, where does all these beautiful code segments come from? What is included? If you read the publication, you have GitHub. GitHub is the main source of the training data. If you have GitHub issues, they use natural language conversation from GitHub issues and pull requests. Yes, it's all included in the stack, and the Git commits. They were all guarded and included in a single file. Beautiful. And what I want to show you, the care this consortium of StarCoder took here to clean the data, to have correlated data, to have high quality data set. So for the training data set to create this, they had a lot of stacks. Yes, of course, there was their stack, their data source, but in the cleaning process completed a lot of filtering here from the 358 programming languages. Just 86 programming languages were selected. They had a visual inspection from community annotators to look through. You have an XML filter, you have an alphabetic filter where they say, hey, we remove any files with fewer than 25% alphabetic characters, helping identify the data. They have an HTML filter that was designed to manage files where the visible text constitutes at least 20% of the HTML code. They have JSON filter, YAML filter, Jupyter notebooks. They cleaned up everything. And it is so important that we have this open source exercise by the community. Yeah, they have 40 hidden layers, and there's a special infilling I want to explain to you a little bit later, because it is really important for the performance and for the architecture of the system. And just want to mention 2 additional facts they use here for the calculation of the attention tensors. They use flash attention. This is an optimization for the internal processing, how the algorithm compute the attention mechanism itself. And this here is especially an advantage, if you want, because you can scale now to context length of 8K token length. And plus a lot of questions last time about the tokenizer. They use here a byte pair encoding a BPE. This makes sense. This goes down to single character letters. And the vocabulary size is impressive that it's close to 50,000 tokens. But if you think about the number, the sheer number of programming language, I would say that it is below 100,000, the vocabulary size is also remarkable. Now, let's evaluate this and let's see how good is this system. Now, there are a lot of code completion benchmark. I pick here from their publication 1 DS1000. You have 1000 Python data science problems. And you can see here you have the completion problem given and the code insertion test. So encoder, this was one of the things by the company Facebook or Meta. You see here in the first line, it's a 6 billion parameter model. And then you see here for StarCoderBase and for StarCoder their performance. And now for different Matplot, NumPy, Pandas, PyTorch, SciPy, Scikit-learn, TensorFlow, you see here the performance. So give you an idea as a base. Here we take here encoder 28. You see StarCoderBase goes up to 47, and StarCoder itself on the Python optimization run achieves 51.7. And you see this is more or less a consistent picture that goes through. And if you look here at encoder from a 6 billion parameter model, overall 7.4, you go with StarCoderBase 23.8, and then you have 26. And if you do the same exercise now on code insertion, you see that the results are more or less consistent. And please notice the jump here from a 6 billion parameter model here to just a 16 billion parameter model that is also has advanced architecture is significant. Beautiful. Now you know about the performance of StarCoder and StarCoderBase and encoder. So, and next time we are gonna talk about fine-tuning here our first code LLM, StarCoder.